So, hi, welcome to day 7 of 30 days learning embedded systems. Today we are going to learn about serial communication, UART, and debugging. So, have you wondered how Arduino talks to your laptop? How sensor data appears in your monitor? Today we are going to learn about it in a brief manner. So, before getting into the video, what's communication? In Arduino, so it would be like the sensor detects the data which is going on, which is the main function it is capable of. It sends the data to the microcontroller access the brain for it thinks what to do and sends it as the output for the computer, and the output is displayed here. So the embedded system does not work alone. It is a combination of sensor, computers, controllers, displays, and IoT model. Sensors capture the data which sends to computer. Computer analyze the data and sends to the microcontrollers. It displays what's the data being captured, and IoT modules help to send the data to the other models for better interactions, which can be observed in homely applications. So these are some industry level example. Assume a car which has ECU, electronic circuit unit, which captures the data. The data is sent to diagnostics for some faults detection. System analyzes and send the feedback to the display or the user for the improvement of the embedded device. So there's a question for you. If an MCU cannot communicate, can it debug the system? Comment down your answer in the comment section. And there are types of communication: parallel communication and serial communication. In parallel communication, the data is sent from multiple wires. Individual data is sent through every wire, and in serial data, the data is sent one after the other. Assume the first bit would be 0 and the next bit shared would be 1, and simultaneously all the data will be shared here. Which data is preferred in industrial use case and why? According to the industrial case, serial communication would be used as it is cost effective and consumes very little amount of wiring and complications. And the next topic is UART working. UART refers to universal asynchronous receiver and transmitter, which is used for converting computer language to MCU language, and the captured MCU data would be converted so that the computer can read the data and display as per the user language. So computer, it would be mainly USB. We plug in the USB, and the USB is converted to UART using the UART converter, which is sent to Arduino UART module, and then it's sent to MCU core for evaluation. And the next topic would be transmitter and receiver, where Arduino board consists of the pins named TX and RX. Here TX refers to transmit and RX receiver. For transmission of data, it is connected from TX to the RX and RX to the TX. If not, the data would not be exchange. This is the ideal case of connecting for receiving and transmitting data. Here data frame structure. This is the structure for the data to be transferred inside the MCU. It consists of start bit, data bits, parity bits and stop bit. Start bit, when the start bit is 1, the data which need to be transferred would be started to transfer, and the parity, if any error is present in the data bits, it would be replaced, and the stop bit indicates the data transfer need to be stopped here. It works on the principle of overflow. The data is being transferred successfully as a cycle. It performs multiple cycles in the same format and the same structure. This data is transferred if and only if the condition of baud rate is satisfied. Baud rate is the technical word which is used for verifying data transfer speeds. Assume MCU speed is 9600 bits per second and PC is 9600 bits per second. These data could be easily transferred compared to different speeds. When both the speeds matches, the baud rate is same and it is easy to transfer data. In this case, the data transfer is not possible. Explain how is it dangerous if the baud rate does not match. And the last topic is serial debugging. The flow chart would be going like program running, serial print, serial monitor and developer read. So we write a program for let's say an temperature sensor. We write the program and thus using multiple sensors it detects the temperature and the temperature is print in the console and which is then displayed on the monitor. If any changes need to be done, it will be changed by the developer. The output, you can see the uses. It is to check sensor values, detect bugs, verify logic, monitor status. Here are some real life examples which I have told now. Temperature sensor, MCU and serial communication and display. So that's it for the video. Let's meet in day 8.